The fuck was that? There's some low light compensation shit on the camera, and it makes it go down to like 30 frames or worse. Oh, fuck. Of course, I smudge my glasses right when I do that too. Alright. So last time we were talking about stack behavior, and I think we were getting into how a stack is actually implemented in C++. Learn CPP mentioned that in some languages, a stack is its own distinct type. But it seems like that has to follow with a but. For example, French people eat snails, but their neighbors next door, like, it's not French people eat snails, and that's a great choice, and we do too. It's always A, but B. It's never A with a question mark at the end and B. Like, what? That doesn't make any sense. Or A and A in this case. All right. In some languages, this is how it is. It's limited in this case. If we want to print all values in a stack and all we have is pushing and popping, then that by definition modifies what's in the stack. We can't just view all. We can look at the top. We can check if there are things there by basically looking at the top and seeing if it's empty or not. We can get the size. Sure, I guess you can just sum however many pushes were done. And you can push and pop. That's it. It's a push pop, man. If we want to print all the values in it without modifying it, without pushing and popping, well, how are we going to do it? Besides pop, 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 or push, push, push. Well, I mean, if we had a stack, we'd have to pop, 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 pop. Or just know each of the values as they get pushed onto the stack. In C++, stack-like operations are added. Okay. Added to the existing classes that support efficient insertion and removal of elements at one end. I'm not sure how that works for a standard vector. I mean, so far we just increase the size by 1 and then add the size minus 1, or add something to the index of size minus 1. Unless there's like an insert and then you pass the index of where you want it to be. Standard list, standard vector, and standard DQ? Or is that deck in French or something? Or maybe that's that DK that we keep hearing about for C-style arrays. Okay. So we have specific operations. This is a long one, looks like. Maybe not? It's actually not even long. Ow! Oh, we do see this pushback and pushback stuff. Oh, would pushback be adding something? Well, oh, pushback would be adding something. It would be pushing something onto the stack. That makes sense. Because if we have 1, 2, and 3, and we push 4 on top, we are pushing 4 to be on index 0, which means whatever was index 0 now needs to be 1, and whatever was 1 now needs to be 2, and whatever was 2 now needs to be index 3. So we are pushing back. We're pushing back these things to put somebody on top, or we're putting someone on top, which pushes back the rest. Gotcha. Better analogy. Instead of a stack of plates that can vary in the number of plates that it's holding, bro, what? A bunch of mailboxes. They start out empty. We have a bunch of mailboxes. The top one has spikes, so we can't insert them on top or below between them. So we can't even change the number of them. Makes sense. Oh, the top of the stack, the lowest empty mailbox. Oh, gotcha. Because if things are filling up, then the lowest empty one is raised, and this is the top of the stack. Okay. So at first, the top of the stack is actually at the bottom. It's a weird ass analogy. Okay. When we push something onto our mailbox stack, we put it in the mailbox that is marked and move the marker up one mailbox. Gotcha. So we have our top guy, and we can't add new mailboxes. We have some limit, so I guess a stack is limited. What we can do is we can put something in the first mailbox, and then we take that sticky off and put it on the next one to say, hey, you're now the top of the stack. So we can tell how many items are in the stack. Okay? By just counting up to the sticky. And when we pop an item off the stack, we move the marker down one and then empty it out. Okay. Makes sense, because if this guy was full, this guy was the top one, and we empty him, put the sticky on the bottom. Now he's the top empty one, or the bottom empty one. Or, well, in that case, the stack's empty. But items below are called on the stack, and ones are called not on the stack. At or above are not on the stack. Now, call the marker length. Makes sense, because we can count how many, and then capacity is the total thing. Excuse me, gotcha. Gotcha. So assuming we can't reallocate and we have a standard vector of some size, let's say it's got 5 elements, so from 0 to 4, we could say, okay, I've put something in. It has length 1 now instead of, so it has capacity 5, and let's say length 0. Then the length is 1. We've pushed something onto the stack. Interesting. Yeah, instead of thinking about it like pushing something on top and then pushing down, it's like pushing, it's like pushing into. Yeah, but isn't it LIFO or is it FILO? Is it first in last off or is it last in first off? It's gotta be LIFO, right? Because if that, I guess, I don't know. I don't like this analogy. I like the plate stacking analogy more, because if we put a plate on top, the plate has to come off next. That has to be the one we take off to get next ones. Versus, the only thing there is that, like, no, yeah, just pretend that the plates can only be stacked so high. Well, I guess the point there is that it binds capacity and length together. But maybe pretend that we have like a stack of empty plates, and then we put a plate inside, and then it's kind of hard to do perfectly. But okay. How the stack interface of standard vector works. Solve the challenge introduced at the top. Talking about dynamic memory allocation, meaning that we allocate some memory, and at some point it comes off, and then at some point more comes on, and maybe even more comes on, and then it comes off. But those seem like they're calls, not, I mean, those make more sense with function calls and not dynamic memory, because I don't think anything says that one has to be destroyed before another. Stack behavior has these: push back, pop back, push pop, back, and M place. Do we just mean the last index? which would be the length. And back is actually the one that looks. Hmm. Ow. Okay. Can I not fucking type? Alright, what else do we want? What if we push something on so we can first just print the guy? Well, hold. I'd have to print each. What if we do that? We could also do, whatever. Okay, so you can print 1, 2, 3. This thing will ever fucking build. And then we could say x dot push back. We put 3 again, and then vector x. Is it 3, 1, 2, 3? Oh, what the fuck? Oh. What in the hell does this do? So it's 1, 2, 3 at first. Right? Oh, the point. Hold. Okay, here it is. Never mind. I'm retarded. Okay, 1, 2, 3, and then 1, 2, 3, 3. So it does. It puts it on the end. Okay. So we have index 0, 1, 2, 3, or well 0, 1, 2, and then another guy gets put on top, and then they can be popped back off. Okay. So we can do this, and then we could say x dot pop back, and that just removes the last one. And then we could say same thing to get 1 at the end, or wait, hold. 1, 2, 3. We add 1. Oh, yeah, that's right. Wait, what? Hold. So we're printing 1, 2, 3. Oh, we haven't printed again. God, I'm such a fucking idiot, dude. Okay, now it should be the same. Or, sorry, 1. So basically what we did was this. We had 1, 2, 3, which we printed the whole thing, the whole vector. The whole stack. Then we do push back 3 to put 3 on top of the stack. So now we get 1, 2, 3. 3. 1, 2, 3. 3. And then we say, pop that 3 off, pop the next 3 off, pop the next 2 off, pop, 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 3, 3, 2. Because it's 1, 2, 3, 3. Pop, pop, pop. 1 left over. Print 1. 1, 2, 3. 1, 2, 3, 3. 1. Cool. And then, what if we do x dot peak, not peak, back. 1, 2, 3, 1, 2, 3, 3, 1, 1. 1, 2, 3, 1, 2, 3, 3, 1, 1. Cool. And all that's doing is just getting the. Seems like the top one, huh? Yeah. Yeah, makes sense. Okay. That's back. This could be no, it can't, because standard character output's not known at compile time. Can't put const expression in front of the function. Nope. Oh fuck, I'm gonna crash. You can just tell. Removing sleep is not the play. Maybe not. And so in these cases, can be more efficient. So in the event that we are pushing back and we haven't popped the pop backed first, which I think would reduce the length by 1 but not the capacity. But then when we push back, we regain that length and the capacity is the same. But if we push back full where the length and capacity match, it increases the length by 1, which by definition has to increase the capacity by 1. And if that's the case, I think this means it needs to reallocate. So it needs to find somewhere else that can hold 6 elements, copy 1, 2, 3, 4, 5, and add this guy here. Boom. But mplace, maybe if I'm thinking about this in word sounding, I almost think of in place back. So see if the next piece of memory is taken up, and if it isn't, then just push it on top there and don't reallocate. Or I guess reallocate, but not fully, just add an extra, but I'm not sure. I'm not sure if this is true. Okay. God damn. All right, we have a stack empty, so it's gonna print fucking nothing, I guess, huh? Yeah, capacity and length. Oh, I don't even see what print stack is, so I guess this is just printing the length and capacity. If stack.empty, output empty. For each element in the stack, output the element in the space. And then output capacity, length. Okay. So we'll say empty. Excuse me, sorry. Excuse me again. We say empty. Well, there's nothing here. Capacity 0, length 0. And then we push back. So now it has 1. Does that mean it goes 1, 1? So is it 1, 1, 1? 1, 1, 1. We push back again, 2. Now it's 1, 2, 2, 2. Oh. And then it's 3, or hold, 1, 2, 3, 3, 3. Because we're printing the whole guy, and then we're saying the length and the capacity, or capacity and then length. We could say the top is back 3. And then we can say pop back 1, 2. Is it 3, 2? Or, oh, sorry, hold on. It was 0, and then it was 1, 2, 3. Wait. So the stack at first was 0. We push back 1 to give it a capacity and length of 1. And then again for 2. And again for 3. Right? Why is capacity 4 there? And then I could see if we pop it, the capacity staying the same, but we're popping things off, so it goes to 2, 1, 1, and then nothing. Yep. Why is capacity going to 4? So if we only did pushback 3 times, I don't know why it would go from 0 to 1 to 2 to 4. Or instead of 1, 2, 3. Because it's 0, 1, 2, 3, but the capacity somehow jumps. Excuse me. Mm-hmm. Pushback and in place back will increment it and cause a reallocation of capacity. Okay. So it seems like even in place back won't help with it. Bro. But why? Oh, okay. Extra capacity. Okay. Wonder if it does that when it sees that there are multiple increments, or how that'll work. I wonder when it is that extra memory gets, or extra capacity is allocated. Pushback and then placeback will both increase it and cause reallocation if the capacity is not sufficient. So they will basically increase the length, which forces capacity increase. If length equals capacity. Extra capacity from pushing. Excuse me. It will typically add extra capacity. Okay. And maybe it adds more depending on the size. So the bigger you get, the more extra capacity there already is. That way, whenever you're doing pushing or resizing, well, I guess resize always does it, but that way when you're pushing, there's room so that you don't have to reallocate every time. The compiler's implementation of standard vector. Okay. Really? Visual Studio multiplies the current capacity by 1.5. Oh, shit. So it goes from 2 to 3. And then it would go, I guess, to 4, but maybe it rounds to 5. And then it goes to 7, but maybe 8. Okay. Depending on the compiler. Resizing a vector doesn't work with stack behavior. Makes sense. The longer it is, the more longer it is, the more you got to go. The more you have to reallocate. The more you have to reassign. We could avoid being allocated 3 times if we manually size it. So in the beginning, instead of saying, hey, it's empty, instead we say, hey, it has 3 values. Oh. 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 Now we get capacity 3, length 3, and when we push, oh shit. Hold, so there's 3 elements. 0, 0, 0. And when we push one on top, it's pushing it on top of those zeroed elements. Because it's treating the stack as the vector. Not as, so the stack is not empty by default. When we put 3, it thinks that there are 3 actual stack values. So you push on top 1, and then a 2, and then a 3, and the capacity doubles, I guess, for GCC or Clang. Whereas it would go to probably 4.5, so 5 maybe. And then the length goes up, goes up, goes up. Top is 3, and down, down, down. This is the initial size. And the resize set the capacity and the length. So if we set the capacity to be 3, well, the length also got set to 3. Yep. Is there a way of just setting capacity? Oh, reserve. Okay. So resize matches both. Okay. Oh, I gotta go to the bathroom. Be right back.